Hello friends, in this lecture we are going to learn about a problem that is known as 15 puzzle problem. So what is 15 puzzle problem? So first we will know the problem, what is it? Then we will try to know how we can solve it using a branch and bound method. Okay, so first let's see the problem. You are given a 4x4 board, okay, kind of a board where you have numbers. Okay, so this is my initial state, okay, where I have 1 3 4 15. So there are 15 numbers from 1 to 15 and there is one empty cell here. Okay, so this is an empty cell. Now you have this empty cell can be moved to the left. Okay, this can be moved to the right. If I move it to the right, this slot will become empty, 5 will come here. Okay, if I move it to the left, 2 will come here and this will become empty. If I move up, the empty space 3 will come down here, empty will be this one. If I move this down, 6 will come up and this will be empty. Okay, so this is there and you have to come from this to this final state. In the final state I have 1 2 3 4 5 6 7 8. So in each of these cells these numbers should be there and there should be empty space here. Okay, so you understood the moves. I can move the slot up, down, right and left. Okay, but if your empty slot is here, so you cannot move to the right. Okay, so this is there. So how many moves are needed? You have to search how you move this empty slot so that you can go from this state to this final state. So now we want to solve it. One way is kind of depth first search. Okay, so I keep on trying. So I first move here, okay, and then we try out again using this. What are the other 3 possibilities? So now from here I can go what way? I can go then to left or to right. I don't want to go down again because this was already in the parent's place, so I go to left and right. Then if I go to the left, I can again, so this will be empty, I can again go to left or to bottom down, and this way I can try. But the thing is, it will require a lot of moves. Okay, so depth first search is usually not a good way for searching. Okay, the better method is best first search. Okay, so here what we do, my goal is to go from this state to this final goal state. Okay, and I want to find, okay, how many minimum moves I can go. So the thing is, I would like to estimate what is the cost from moving. So from here I can move this slot up, empty space up, down, left or right. So if you move it up, so this slot comes up 1 2 4 and 3 comes down here, if you see. Okay, if you move it right, 8 comes here and this goes to the right. If you move it down, 7 goes up and this empty space is here. If you move it to the left, 6 comes here. Okay, this is there. So now we have got 4 branchings. Okay, so from initial state I can go to these 4 particular states. So let's number these 1 2 3 4 and 5. Okay, now the thing is, which one of them should I try? Which one is better? So what I do is I try to find a kind of lower bound on how many steps do we need to reach the goal state. Okay, so lower bound will tell us that, okay, minimum I have to move these many times before I can reach this state, goal state. So what I can do is that, okay, let's try to see at how many places these numbers are different. So 1 is at the same place here, 2 is at the same place here, then your 4 is also fine, 5 6 are fine, 7 is not correct here. Okay, so one place we find that we are not at the correct place. So we try to find at how many places we are different from the goal state. So in this one we find this is fine, 5 6 are fine, 1 is this one, 8 is also fine, 9 10 are fine, 7 is here, this is wrong. So 2 misplaced thing, 12 is there, 3, okay, then 13 14 15 are fine, and this one. So 4 places are there at which we are different from the goal state. So at least these many moves I need to make. Okay, 3 needs to be placed somewhere else, and then you need to have 7 also move to somewhere else, and so on. So at least 4 moves I will need, and already have made one move. So our estimate of lower bound of moves is cx with upper cap is equal to fx plus gx, where fx is the number of moves from the initial state that I have already made. So x is your state now, which is 2 here, 3 here. So I have already moved from root to this one by one move. So fx is 1, and gx is the number of non-blank tiles not in their correct place, okay, final position. So that is that many moves you at least have to make to reach the final state. Okay, so this is there. Now what happens is, similarly we calculate this lower bound, that okay, at least I will need that many moves. So I calculate it for state 2, for 3, 4 and 5. So let's calculate for state 3. So 1 fx will be 1 because I already moved one time here. Then for state 3, 1, 2, 3, 4 are fine, 5, 6, 8 is not correct. Then 9, 10 is fine, 11 here it should not correct, 12 here it should be, it's 11, this is not correct, 13, 14, 15 are fine, this is not correct, it should be empty. So 4 places again. So this is C3 is 1 plus 4. For state 3 it is 1, 2, 3, 4 are fine, 5, 6, 7, 8, 9, 10. Here 12 should be there, it's 11. And then 13, 14, 15 are fine, this 12 is wrong. So 2 places it's incorrect. So it is total C4 upper cap is 3. Similarly for state 5 it is 5. So now I know that okay, I branched from state 1 to state 2, 3, 4 and 5, and I found that okay, the minimum cost possible, most promising one is state 4. Okay, because it says that okay, lower bound for going from this state to the goal state is just move 3 moves. Okay, so in fact 2 moves from here. Okay, so this is the best one, and I take this branch. So now I branch from state 4, so I can go to right, down and left. I don't go up because I will reach again to the parent state. So I try these out, 6, 7 and 8. So right if I go 11 comes here, down if I go 15 comes here, if I go left 10 comes here. Okay, so this is there. Again I try to see okay, what are the lower bound of moves for moving from these states to goal state. So here if I see 1, 2, 3, 4, 5, 6, 7, 8 are fine, 9, 10, 11 is also fine, 13, 14, 15. Only this is at its wrong place. Now I have already moved 2 times. So 2 is there, fx is 2. This state if I move here, it is just I'm done. Okay, so this one place is wrong. So total lower bound is 3. Here 1, 2, 3, 4 is fine, 5, 6, 7, 8, 9, 10, 15, 11, so 11, 12 should be there, 13, 14 is fine, this is so 3. This is cost is 5, this cost is 5. So now you just don't have to branch from here. I can branch from this place also. So I have live nodes, this one, 1, 2, 3. This I have already branched out, so this is not live now. These are there. And which is the minimum cost now? This one, only 3. So now I branch out again. From here I can go up and down. So I see if I move like this, I have reached the goal state. So this is there and I took 3 moves. Okay, so this is the goal state. So this is the branch and bound. Okay, why branch and bound? Because at each step I try to calculate the lower bound. Okay, what is the lower bound of, or the lower bound or number of moves to reach the goal state, and then whichever was the most promising I try to branch from there. Okay, so this gives me the solution. Okay, so branchings I will make from the best first search. This is the best first search, and this helps because I'm not, if you use depth first search you will have lot of branchings without getting any solution, you again backtrack. But here with best first search you try to always go to the right branching. Okay, so this is there for 15 puzzle problem. I hope you understand it. Thanks a lot.